Okay. Good morning, all. Okay. Science is the process of learning about the natural world through observation and experimentation. It is fundamental to modern life, driving technological advancements, improving healthcare, and critical thinking to solve global challenges. Without it, society would lack modern innovations, medicines, and understanding of the natural world. So now I welcome Director URSC, Shri M. Shankaran, Chief Guest of the event, Professor Ajit Parmeshwaran, Guest of Honor, Professor Sivarani Tirupati, and Chairman, National Science Day 2026 Organizing Committee, Shri Ramesh Naidu. All URSC Council members and all the teachers and students present here. Ladies and gentlemen, and dear students, good morning one and all. I, Rupali Sahu, on behalf of National Science Day 2026 Organizing Committee, would like to extend a warmest welcome to celebrate National Science Day, a day dedicated to the spirit of science, discovery, and innovation. The day is celebrated for the discovery of Raman effect by Sir C.V. Raman in 28 Feb 1928, for which he was awarded Nobel Prize in 1930. The day aims to promote scientific temper, raise awareness of scientific developments, and encourage scientific culture. The theme for NSD 26 is Women in Science Catalyzing Viksit Bharat. This theme focuses on empowering women as leaders and innovators. To begin our National Science Day 2026 valedictory function, I request you all to please stand up for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you all. I now request all the dignitaries to please grace the seats on the stage. Shri M. Shankaran, Director URSC, Chief Guest Professor Ajit Parmeshwaran, sir, and Guest of Honor Professor Sivarani Tirupati. I request Chairman NSD 2026 Organizing Committee, Shri Ramesh Naidu, to please accompany the dignitaries on the stage. Thank you to all the dignitaries. Work as if everything depends on you. Pray as if everything depends on God. Keeping the faith in God alive, we request Ms. Ekta Gangwar to render the invocation.
वक्रतुण्ड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा. दाता तु गणपति गजानन गजानन भजती तुझसे ही गुणी जन भजती तुझसे ही गुणी जन शिरावर गौरतनोवर कस्तूरिकेशर निर्गुण निर्वधि सकल कलानिधि हे प्रभुवरा अमरनायका हे शुभ करा भावे घड़ी घड़ी आलो शरण दाता तू गणपति गजानन दाता तू गणपति गजानन शुण्डाउदरी वलली अभिनव कान्ति मनोहर रूप नवो नव रुंझन चरणी बाजित किंकिणी हे नटवरा ललित लाघवा हे प्रिय करा भावे घड़ी घड़ी ए स्मरण दाता तू गणपति गजानन दाता तू गणपति गजानन दाता 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 तू गण ग गरि गरि सनी सनी पगा नि पगरे गा परे ग सरे पनि सा गा पनि सा रे पनि सा दाता तू गणपति गजानन दाता तू गणपति गजानन भजती तुझसे ही गुनी जन भजती तुझसे ही गुनी जन दाता तू गणपति गजानन दाता तू गण दाता तू गण दाता तू गणपति गजानन
Thank you, madam, for such a beautiful prayer, which invoked the spirit of the event. We'll now have our traditional auspicious lamp lighting. For this, may I now warmly invite our esteemed dignitaries to come forward and light the lamp. I request Ms. Yogita Mathpal to felicitate the same. Thank you all. May I now request the personality leading National Science Day 2026 celebrations at URSC, Chairman NSD 26 Organizing Committee, Shri Ramesh Naidu, to kindly welcome one and all present here.
Respected Director Shri Shanksan Sir, Chief Guest of the Day, Professor Ajit Parmeshwaran, and the Guest of Honor, Professor Shivrani Madam, URSC Council members, my team of volunteers, my colleagues, my friends, and most importantly, today's two guests, our children and teachers coming all the way from various places, also the prize winners, as well as the people who are watching this live on YouTube, students and children. Good morning to you all. National Science Day, as Rupali Madam was telling in the beginning in her introductory, this one, it has been declared to commemorate the discovery of Raman effect by Professor C.V. Raman. And we are celebrating, this is one of the important science festival in India. And this is celebrated with passion and enthusiasm across India. That is what I see. Whenever we were talking to any of the science dignitaries, they are normally occupied. We were actually very happy to have two of the science dignitaries here. So the purpose of this conducting this National Science Day to inculcate the logical reasoning, scientific temper, and the mindset of inquiry in your mind, young minds. And URSC has been conducting this National Science Day for a very long period, at least for 40 years. And it is the longest running outreach activity of our center. As part of this outreach activity, URSC invites the students and children and conduct competitions for the children which trigger the scientific thinking and the scientific temper. And we culminate that events every year on this day, National Science Day. It is a mela of students, mela for the children. And the vigor with which we have been conducting this has been always steadily growing. And the enthusiasm is always there to encourage the young minds. So various events are conducted, I told. Last year also around 7 events were conducted and over 2-3 weekends, Saturdays. And we had around 650 children participating in the competitions. We thought maybe a little more, maybe 700 students and 800 students and children may participate. But this time, we plan to conduct the whole competitions and events on the same day. Maybe that is the reason, I do not know. The response was overwhelming. 1,100 plus registered, around 1,000 plus students and teachers participated in the events conducted last week. Our alternate chairperson, Balaji, is going to give a report on this. Before going further, particularly when I brought up this issue of this point of the events conducted last week, I would like to put on record and my acknowledgement on the efforts put by my team, right from alternate chairperson Balaji, Vishwanath Sharma, member secretary, conveners of all the events, 7 events. There are 7 events, 7 people. I will not take all the names. And Rupali is one of them. Chidambar Kulkarni, Vishwanath Tirlapur. There are 7 people who, Sharanappa. And there were another set of 6-7 committees, subcommittees who were carrying out these activities, who were the backbone for these things. Logistics committee, the budget committee, headed by Suja, accounts officer, our canteen committee. So all these people, they not only, the conveners of the events actually crave the food for thought for your minds. But our other people, they ensured that the logistics are smooth, particularly Satyanarayan Pandey and team. They have ensured that the food for your stomach also is fantastic. Last week, when I was interacting with students, I was particularly asking about how was the arrangement, how was the food, because that's one of the important aspects. And I was happy to say that everybody went satisfactory, happy that they have attended the program, participated in the various events, and had a nice food and gone home. And I'm really grateful to my team. Now coming to my duty of welcoming, our director Shankaran sir is a versatile personality. He is a dynamic leader. He leads from the front. And he motivates and inspires us to do better in every aspect of our work. Not only that, at the same time, while guiding us, he gives us enough freedom to implement new ideas also. I thank you for your guidance, sir. I welcome you, sir, for the program. I request Gautam to welcome sir with a sapling. Thank you, Gautam. Now, while we were planning for the program, we were naturally the question comes, who is the chief guest? And this is being a very busy day across India. Very difficult to get a chief guest, and just two chief guests of repute. And so we were shortlisting, and we had these two names, Professor Shivrani Tirupati, Professor Ajit Parameshwaran. These two were there. I'll tell you a little secret, particularly people are in the high school students. I had an indirect interaction with Professor Ajit Parameshwaran when he was actually scheduling or conducting the Professor Vishweshwara Memorial Talk, which was, first talk was given none other than by Professor Kip Thorne, who was instrumental in discovery of gravitational wave, and Professor Vishweshwara also was part of that. And I understand today that Professor Ajit Parameshwaran also was working in that area, and his area is strong lensing of gravitational waves. And we also had Professor Shivrani Tirupati. We randomly started inquiring, we will call one by one, and we were happy to see that Professor Ajit Parameshwaran immediately accepted our invitation. And I thank you, sir, for accepting invitation and coming here. I request Aarti Gupta to welcome Professor Ajit Parameshwaran with a sapling. Now, I'll tell you the another facet of this. When we received, I talked to Professor Ajit, and I sent a formal invitation. He responded by mail. Next day, we received a message from Government of India saying that this year's theme is Women in Science Catalyzing Vikasit Bharat. So we thought, we have a good chief guest. Why don't we invite? And see, it is like, I don't know whether you people remember, some of you people, the advertisement of Cadbury Declaration. Ek laddu mila kya? Right? So for us, ek jhatke mein do laddu mil gaye. So it was an opportunity for us to invite Professor Shivrani also, because it was complementing this year's theme of National Science Day. So we contacted Madam. She was very happy to accept our invitation. And here Madam is there. I request Dr. Prasad BS to invite Madam or welcome Madam with a sapling. This is what I call as the do laddu ek jhatke mein. The reason is we have two magnificent personalities in the area of science, physics particularly. One actually is a specialist in gravitational waves, strong lensing of gravitational waves and related work. He's been working since last 5 years. That is what I was told. And Professor Shivrani, who is into archaeology of the universe. She is into that area, and she is a very good instrumentation engineer also. That's what I was told. So we are here we are happy actually and we are lucky that we have two dignitaries here to actually ignite our minds. Thank you, both of you, for coming here, sir and madam. I invite the council members, the other senior members of our URSC, and most importantly, the prize winners of today, 103 students with their teachers. They are here winning various competitions conducted last week. I congratulate them and I welcome them for the program. And we have 363 students. I don't know how many are this one. I believe around at least 350 students are there who have come from around 9 different places. From Gangavati to Maddur to Kolar, some 9 different places. 3 places are from Bangalore, the schools are from Bangalore, rest of all are from outside Bangalore. So I welcome all of you. Thank you for coming here. Hope this program and the talk by our dignitaries triggers your mind, inspires you people to do things for the country in future. And lastly, I welcome all the people who are watching this program live on YouTube. Welcome to you all. Thank you. Jai Hind.
Thank you, sir. Now, on behalf of organizing committee, we would like to thank NSD 26 chairperson, Shri Ramesh Naidu, with a sapling. I request Ms. Vinti Bhatia to do the honor. Thank you, sir. Several events were conducted during the National Science Day celebration for this year, and the participation was huge from various schools, teachers, and students of all standards. The number was around 1,000. There were total 1,000 in numbers. To brief this gathering of various highlights, we call upon the alternate chairman of NSD 26 Organizing Committee, Shri K. Balaji. I request you, sir, to please present a report on National Science Day 2026.
Thank you, madam. Good morning to everyone. Science holds a great importance in our lives. Today we are celebrating National Science Day. The main objective of National Science Day celebration is to instill, ignite, rekindle scientific temper and promote the science awareness to reach out to every Indian. This day celebrates across India with a great passion and enthusiasm. URO Satellite Center, a lead center of Indian Space Research Organization, ISRO, responsible for research and realization of Indian satellites and related technologies, has organized multiple events this month under the theme of Women in Science, catalyzing Viksit Bharat by Government of India. We are pleased to report that more than 105 schools and 966 students registered online for the NST competition this year. Among them, about 865 students and 140 teachers, making a total of 1,005 participants from the 66 schools to actively took part in the 7 events conducted on the 21st February, means last Saturday. We had an overwhelming response from schools in and around Bangalore and faraway places like Tumkuru, Kolar, Mysore, Ballari, Gangavati and Bagalkot of Karnataka, and also some schools from the neighboring states. Now, let me give a brief report on these events. To encourage the students to think and work in a team, model making competition used for primary and high school students. High school students were provided with raw materials such as chart paper, toothpicks, and glue, etc., to design and build a model on the topic working hydraulic lifting arm. And for primary school students were tasked with constructing and demonstrating a static model of Chandrayaan-3 satellite. A total of 78 teams, each comprising of 3 students, participated in this event. To foster the scientific thinking among the students about day-to-day activities happening around us, and also to encourage the critical thinking, inquiry based on learning and problem-solving skills, an event called a Test of Scientific Temper was conducted for the high school students. The students were encouraged to give answers what, why, and how the things will happen based on the scientific principles, original ideas, equipment involved, and logical reasoning for choosing the solution. This was a 3-member team event, and about 114 students from 38 schools have participated. Hope this event is inspired young minds and strengthening the scientific engagement at a grassroots levels. A special event titled Teachers Insight was organized exclusively for the school teachers. As a part of this, teachers were asked to submit an essay on the topic, The Synergy of Intellect, Human-AI Collaboration in Modern Science. Based on the evaluation of these essays, 16 teachers were shortlisted for a panel discussion round. The panel discussion provided a valuable platform for educators to share the visionary ideas and how the synergy of human and AI can drive the future scientific innovations. Extempo Science Elocution was another event held separately for primary and high school students. This event was aimed to improving the students' oratory skills, critical thinking, and their judgment on the topics given. Confidence as well as the testing their knowledge on various topics such as science in daily life, biodiversity, space missions, their vision about space, their dream laboratory, textbook science, etc. It was an individual event and students were expected to speak for 3 minutes About 80 students from different schools are participated in this event. And an event by name Science in Action was held in ignite the enthusiasm and curiosity for the science among the young minds. The event brought together 78 students from various schools to explore, question, and engage with the science behind textbooks. This event was an interactive and live demonstration of 12 scientific experiments conducted by our engineers. After demonstration, the students were asked to write answers to a small quiz to test their understanding, observation skills, and ability to apply scientific principles. The event was aimed to recognize, encourage experiments that spark the curiosity and excitement among young scientists. The spot painting competition is aimed at the creativity, awareness, nature, creativity, originality, spontaneity, and artistic expression among students. The theme was announced on the spot for all the three categories to think, imagine, and transfer their ideas into visual form in the stipulated time. The competition was held for primary school students from 1st standard to 4th standard with the topic, When I Become a Scientist. For primary schools with the topic of Science Education Empowering Girls. And high school students from 8th to 10th standard, which is the topic of My Vision of Viksit Bharat. About 225 students participated in this competition and expressed their ideas throughout vibrant and imaginative artwork. The last one is a science quiz was also organized to explore the science and general knowledge skills among high school students. 40 school teams of 3 students each participated in the first round of written test. Based on that, 6 teams were selected for the exciting grand finale. The final quiz was thoroughly designed to ignite the scientific curiosity and nurture a passion of innovative and STEM education among young minds. The competition focused on the key themes including women in science, Nobel laureates, general science, future technologies, and space science. The final quiz featured engaging rounds such as clue, buzzer, visual round, etc. The program reinforced URSC commitment to inspiring the next generation of India and fostering the strong culture of scientific temper among school students. The biggest attraction was exhibition and showcasing the making of satellites. A total of 18 stalls were set up to explain the fundamental scientific principles involved in the satellite development. To emphasize the basics of science used in the satellites to students, 10 groups from URSC showcased their products and technologies, providing the students with hands-on exposure how satellites are made. Real-time tracking of geosatellite and image processing demonstration draw a significant attention from both students and teachers. A panel of experienced and competent judges evaluated all the 7 events with great diligence and fairness. Winners of each event will be honored with first and second and third prizes along with the consolation prizes. In conclusion, we extended our heartfelt appreciation to all the participating students and teachers for their enthusiasm and commitment. We also congratulate all the prize winners. The success of National Science Day 2026 celebration reflects the URSC continued dedication to promoting the scientific temper and inspiring the next generation of innovators. Thank you all.
Thank you, sir. Let us all watch a short video where we'll see the glimpses of NSD 2026.
Okay, now we'll be announcing category C names.
transmits the information. Yes, it should reflect the age.
Or one ball will move with the same velocity. Because
which make life possible.
In space and in vacuum.
Here we see suns very safe from the UV ultraviolet.
Things would not work. Let's see our
The
mobile.
main reason for this is that
The red light, the light travels through the moon.
I give more than 5. I give more than 5. Can you
Global City International School. My name is Kiran.
Training.
Intelligence, which relation
Thank you all. The epitome of knowledge and experience, one who with his dynamic personality and focused approach has spearheaded various missions of national pride such as Chandrayaan, Gaganyaan, NISAR, SpaceX and BAS, etc. Under his leadership, we are now advancing towards various projects such as manned missions, lander missions, space re-entry and sample return missions, docking missions and many more. The personality who empowers us, inspires us and encourages us to achieve more is our beloved director, Shri M. Shankaran. We welcome you, sir, to inspire the gathering in this occasion of National Science Day with your presidential address.
Thank you, Rupali. Good morning. First of all, let me welcome all the students and teachers who have come to be part of this National Space Day, Science Day celebration at the U.R. Rao Satellite Center, the cradle of satellite technology in India. Welcome. Let me also join Mr. Ramesh Naidu in welcoming the chief guest and the guest of honor today, Professors Professor Ajit Parmeshwaran and Professor Shivarani, for being part of this celebration of science. Thank you for making time and joining us. And for the children, I may have to apologize because some of you are now forced to sit on the aisles, couldn't find seats for every one of you, but that is what enthusiastic participation in any event means, and I am very happy to see that this auditorium is full and overflowing. Thank you for that. So I will not ask you or tell anything about National Science Day because all of you will be aware of this, because you have come here, you would have definitely at least Googled and found out, isn't it? Or at least your teachers would have told you why we are celebrating National Science Day. But I want to ask you some question about this year's, okay, it is not there, this year's theme for the National Science Day as declared by the Department of Science and Technology. You see, it is Women in Science, Catalyzing Viksit Bharat. Does anybody know what is a catalyst? Anyone? What is a catalyst? Nobody knows, sir. Simply shout. Yeah, something which aids some action. Very good. Whether this catalyst participates in the reaction? Okay, very good. So, why catalysts are required for Viksit Bharat? You know what is Viksit Bharat, isn't it? Develop India. Should we become independent of Viksit Bharat? Catalyst is not part of the reaction, isn't it? It does not participate in the reaction. Catalyst only aids the reaction. Whereas, when we talk about catalyzing Viksit Bharat, does it mean those who are catalyzing Viksit Bharat are not part of Viksit Bharat? What do you say? Yes or no? Okay. There is a small catch in it, because it is understood that Viksit Bharat is a long-term goal. It is not that tomorrow we are going to become Viksit Bharat. isn't it? We are not going to become a very rich country within next month, next year, even next decade, isn't it? It's not easy. So, those who are catalyzing the growth of this country towards becoming Viksit Bharat may not actually be part of the Viksit Bharat when India really becomes very advanced, isn't it? People like us will be long dead, like me, I am telling, because I am already 62. So, people like me will be long dead. Some of you may be there, some of you may be becoming old, maybe your teachers would have become old by that time. You may be, the younger children may be there. So, the importance of catalysts needs to be understood like that. Those who are today going to make it possible may or may not be part of the set of people who will reap the benefit of this, isn't it? So, does the catalyst worry that I am not part of the reaction? Isn't it? So, this is my interpretation, nobody has told, this is my interpretation, that those who want to catalyze good things to happen are not worried about being part of that good thing when it happens, isn't it? But that good thing has to happen. For that, the catalyst has to do its function. So now go to the first line of this theme, women in science catalyzing Viksit Bharat. Why women in science is important? Does anybody know? Why science is important? First, let us talk about science. Why science is important? What is being scientific? What does it mean? Being scientific means being
Sir,
careful.
understanding the world around us, like through studies.
Okay, that is one of the outcomes. When we say something is scientifically done, what does it mean? Yes. When you do things carefully and logically, anything you do carefully and logically, it is considered as being done scientifically, isn't it? We cannot do science without being logical, isn't it? So, science provides the ability to be careful and logical. Why careful? Because when you are logically analyzing things, the outcome, the negative outcome, positive outcome, everything will be analyzed. So, before we actually commit ourselves to do something, when you think about it scientifically, we also know what is going to be the good outcome, bad outcome, how to be protected from bad things, how do we utilize good things for good outcomes. So that is why scientific is important. Scientific does not mean only physics, chemistry or biology or any other science subjects. Being scientific is being logical, being careful, being iterative and thoughtful. That is what is being scientific is all about. So now you tell why women in science are expected to catalyze Viksit Bharat. Very serious it is. Men don't have?
They increase the rate of the reaction, that is our Viksit Bharat.
Okay. I want to quote Mahatma Gandhi here. You know what Mahatma Gandhi told about women's education? Anybody is aware?
If a woman is educated, the entire family is educated?
Yes, that is what he said, and thank you, ma'am, for that. When a boy is educated, the boy becomes educated. Whereas when a girl gets educated, her entire family, the entire society around her becomes educated. So, is it possible that we can achieve Viksit Bharat by keeping 50% of the members of our society not involved in the process of becoming Viksit? Is it possible? That is the importance of this year's theme for the National Science Day. It is close to the heart of many of us that without the participation of every section of our society, in this case today we are discussing about men and women. Like that there are many other segments in this society. Society is divided by various reasons. By making every segment of this society participate in any event, the greatest example of that is our national independence movement. India's independence movement, this is the most non-violent, successful independence movement ever seen in the world. Generally, independence movements are very bloody. It means both sides kill each other, many thousands and lakhs and crores of people get killed on both sides. A bloody war only finally results in independence of a nation which is colonized. Whereas the amount of life loss during Indian independence, due to the Indian independence movement, is very, very small. That could be achieved only by the participation of almost the entire society, the entire population of this country, right from very rich Maharajas, Zamindars to the poorest of the poor people, men and women, from the northernmost part of the India to the southernmost part of India, easternmost part of India to westernmost part of India. Every area, everybody participated. That is why we could achieve with minimum losses to life, which is sometimes called collateral damage. When we are achieving a greater objective, in the process there will be some unintended casualties. So that is what participation of the entire society results in. Now this year's theme for Space Day is Women in Science Catalyzing Viksit Bharat. The question is now to children only, not for teachers. How many of you are being helped at home to do your homework and studies by your fathers, daddies? One hand is up. Two. How many of you are helped by your mummies, mothers? So all of you are doing it by yourself, neither dad and mother helps, is it? Nobody helps. So from now onwards, we'll call ChatGPT as moms, is it? Seriously, is it? Nowadays, mothers also don't help. See, I'm totally out of touch. See, my entire logic has fallen flat here. At least when I was studying, when I was seeing children being taught at home, it is generally the mothers, isn't it? I don't know, you are all being funny today or not, I do not know. I still believe, I refuse to believe that the mothers are not teaching children. It is my firm conviction and belief that at home, it is always 90% of the cases, it is the mother who teaches the children, and the mother who is more worried about what happens to the studies of the children. Right or wrong? So, if we want to build a society which is scientific, it is important. You people have deflated me, my balloon here. It is like but I still believe that these, at least in India, it is the women who drive the growth and the welfare of the children. It is not that men don't do anything. Men do their own way of doing things, but day to day, following up with the children and attending to smaller needs and what happens on day-to-day basis to the child, I don't think anybody other than mother is doing even today. So that is the reason why I am telling this topic is very, very close to my heart. Because if we want to have India as a developed country, not necessarily powerful country, because power can be defined in many ways. India should become a happy and rich country. Richness both through material means and as well as through other means also. We should be rich in culture, we should be rich in knowledge, we should be rich materially also. So there is only one path, at least in my mind, which leads any society to become rich and developed. That is only the path of learning. That is only the path of informed inquiry and logical thinking, analysis. If these qualities come to our younger members of our society, naturally we are on the right track towards becoming the developed country. That is the reason we have to ensure that. I will tell one statistics about here, this very center, URL Satellite Center. We have about 2,400 employees working here. You know how many women work here? Totally about 25% of this 2,400 people are women. And out of this, about 2,000 people are scientific and technical work people. In this, the percentage is 20%. Do you see the importance of this information? Ideally, being the population ratio between men and women in India is 50-50 plus minus 2-3%. Different states, this is going. Some states it is becoming now -7 for women. There are a couple of states where it has become +2 or 3 for women. But generally overall you can say 50 plus or minus 2 or 3 average. So if the society is equitable and gives opportunity to everyone, then in every walk of life we should be able to see the same ratio, 50% of men and 50% of women should be there. Why it is not happening? Why even the best of the organizations like here URC, only 30% of the total workforce is women, and only 20% of the scientific and technical workforce is women. Why does it happen? It is a reflection of our society. This is nothing specific to our organization. If you go, in fact, our organization statistics slightly better compared to many other organizations. Why it happens is because in general, men or the boys are given the priority in education. When it is a choice of course in college, when you enter the college, boys generally select engineering, go to engineering. Even within engineering also, the girls choose computer science and something like that. The core engineering subjects like mechanical, civil, electrical, the number of women who are joining them is small. Even if you look at commerce and management, number of MBAs, men and women, you see it is very highly skewed in favor of men. This is how the society is there. Now this has to change. To change, is it required to change or not? Yes or no? It is required to change, because I used to tell one story to our people. It is not my own story. It is read by me in the internet. It is a story of a corn farmer. It is a story from Europe. That's why it will be like that. It is the story of a corn farmer. Corn is jola. The corn farmer had a fantastic field. His produce was the best in the entire area. His corn product was so good. So he was making a lot of profit. But what he does is, at the end of each harvest season, the same corn that is grown only will be used as seed for the next crop. What he used to do is, he will used to distribute the seed to all those other farmers who are staying around his farm. The other farmers around his farm also are given the same seed which is from his farm. People were making fun of him. Why you are doing this? You have a great crop. You are making a lot of money. By giving this to all the neighbors, you are making them also to grow very good crop. So you are going to lose out in business, because they will become competition to you. He told, no, there is what your understanding is not correct. I have a different reason for this. He had a very, very important, even selfish reason to do that. He explained that when my corn grows, the crop is produced due to the bees coming and doing cross-pollination of my crop. The flowers in my crop attract bees. Bees come and sit from one flower to the other flower. Pollination happens, so the crop grows. It is able to produce the product, that is the corn itself. Now, the bees doesn't know which is the boundary of my farm. The bees may go and sit anywhere around nearby and come and sit on my crop. So the bees cannot be assured that they will only pollinate good quality pollens from my field. It may come from anywhere else also. So if my neighbors are not doing well in their farm, my farm also over a period of time will get destroyed. So it is in my interest that I need to make my neighbors also to grow good quality product. Then only my product will remain good. Do you see the relation between this and our society? Unless the entire society is healthy, educated, scientific, and economically strong, only a small segment or even a 50% segment cannot thrive. It is essential that everyone around us needs to be as good as, if not better than us, so that our life and our security and safety as well as intellectual growth is assured. So that is the reason women in science is important. This is the message I want to give it to the youngest members of this audience today, that between to the boys I tell that respect the girls. They are no different from you. You have to treat them as if how you will treat yourself. Whereas for the girls, you are no less than your brothers. You are as important and as capable as your brothers. Don't hesitate to go by your mind. If you want to become a scientist, become a scientist. You want to become a doctor, become a doctor. You want to become a dancer, become a dancer. There is nothing that should be dictated by the society's preferences or likes or dislikes. It is you, your ability and your preferences that should guide your future. You being happy is the fundamental first requirement for anything else. You know, can an unhappy person make anybody happy? To make anybody happy, first you have to be happy, isn't it? Then only we can make anybody else. So to make anybody else study well, first you should study well, isn't it? That is the reason why I wanted to bring the mothers teaching children. If the mothers are not scientifically inclined, there is no way the children will learn the scientific temper from the mothers. So it is a very important and apt subject, and I request the teachers must be already doing it. I request every one of the teachers, along with the subjects what you are teaching the children at school, more than the girls, please teach the boys that how they should treat girls. That is the only solution for our society to improve. Science and other things can come second. First one is making everybody, treating everyone equal, treating everyone with respect, treating everyone with the same expectation we have from others. So this is the message I want to give to my young friends here. You are all the future. You are the ones who are going to make India Viksit Bharat. And if India has to become Viksit Bharat, all of you have to become scientific, not necessarily scientists. And you should also believe in equality of everyone on this planet. Wishing you all the very best for your future studies and your career and as a life as a whole. And thanking the guests here for being part of this celebration. I am sure they are going to tell many more scientific things, because I am not a big scientist. They are the big scientists. They will tell you scientific things. but I wanted to tell you the most fundamental thing that will shape this country in the future. Thank you very much. Jai Hind.
Thank you, sir, for the speech. Your insights and vision for future have truly motivated the students and everyone present here. We are grateful for sharing your wisdom and encouragement to the students. Today, we feel honored to have with us our chief guest, Professor Ajit Parmeshwaran, a physicist and Dean, Programs and Activities at the International Center for Theoretical Sciences, ICTS, Bangalore. I now request Shri Vishwanath Tirlapur to kindly introduce the chief guest of the event to the audience. Sir, please.
Good morning to everyone. It's my privilege to introduce today's distinguished speaker, Professor Ajit Parmeshwaran, a leading figure in gravitational wave astronomy and one of India's most accomplished astrophysicists. Professor Ajit is currently working at International Center for Theoretical Science, that is ICTS, at Tata Institute of Fundamental Research, Bangalore. He earned his PhD in 2007 from Max Planck Institute for Gravitational Physics. Early career included postdoctoral positions at Albert Einstein Institute and as a senior postdoctoral scholar at the California Institute of Technology. A key member of LIGO scientific collaborations since 2004. Professor Ajit made significant contributions to the historic first detection of gravitational waves in 2015. For this groundbreaking work, he shared 2 prizes, Special Breakthrough Prize and Gruber Cosmology Prize. His research focuses on gravitational wave astronomy and gravitational lensing of gravitational waves. He has authored or co-authored over 70 peer-reviewed papers along with numerous influential LIGO Virgo publications. His work is widely recognized as a new frontier that promises to revolutionize the cosmology. Professor Ajit's excellence has been honored with many prestigious awards, including ICTP Simons Associate, Lakshmi Narayan and Nagalakshmi Modali Award, TWAS, CAS Young Scientist Award, and many more. He has delivered invited talks at leading institutions worldwide, organized major international programs at ICTS, mentored numerous students and postdocs. A visionary scientist, dedicated mentor, and passionate science communicator, Professor Ajit Parmeshwaran represents the very best of Indian and international gravitational wave research. Please join me in welcoming Professor Ajit Parmeshwaran for today's talk.
Can I use a slide changer? Good morning, everyone. It's if you have one, I'll take it. Yeah. Good morning, everyone. It's a great honor to speak at the National Science Day celebration of the U.R. Rao Satellite Center. I feel very honored. I'm also particularly happy that I am speaking to a lot of the curious young minds of the next generation. So it's a particularly honorable and happy thing for me. we know that astronomy is one of the oldest of sciences. So let me use this opportunity to tell you a little bit about what has been happening in astronomy in the last few centuries, and in particular in the last few decades. So we heard from Sri Shankaran, the director of URSC, how science works, and it's how influential it has been in our lives and the development of modern societies, etc. And I hope that in the course of this lecture also, I will touch a little bit upon how science works by using astronomy as an example. Astronomy, as I said, has been one of the oldest of sciences, and it really reflects, people, our ancestors, at least in the last several thousand years, has been curious about the universe in various ways. And this is something, a basic trait of our species. Curiosity is a basic trait of our species, and I think it is that has taken us to this far to become, sort of the most developed species in planet Earth. So astronomy has a history of at least 3,000, 4,000 years, but it underwent a major change about 400 years ago by the discovery of this very modest instrument called astronomical telescope. And this was invented by other people, but this person, Galileo Galilei, made in some way the best use of it. He appropriated this instrument to look at the skies. And even with this very modest instrument, he made some remarkable discoveries. These are pages from the notebooks of Galileo. This is the phases of the moon. So at that time, obviously there were no cameras. So he had to basically take painstaking drawings of these observations, and you could see how good an artist he was also. This shows that very interesting and detailed images, pictures of the craters and the mountains on the moon. And he realized that unlike what has been believed till then, moon is not just a luminous sphere. It is actually reflecting sunlight, and it has a very uneven surface, just like that of the Earth. It has deep craters and big mountains, etc. There's another page which he recorded the satellites of the planet Jupiter. Until then, the popular belief was that all the planets were moving around the Earth. And it is the very first time someone is seeing that something that is orbiting someone else, which is the planet Jupiter. And these are now called the Galilean moons in honor of Galileo. And it really put a nail to the so-called Earth-centric theory of the universe. And this is another image which shows the phases of the Venus. So just like the moon is going on phases starting from the crescent all the way up to the full moon, by careful observations, Galileo realized that the planet Venus is also going through these phases. And the only way to explain these phases is that if the Venus as well as the Earth is moving around the sun, and if the Venus and the sun were moving around the Earth, you could not have seen such observations. So basically, Galileo put forward these arguments supporting the so-called heliocentric theory of the universe, where all the planets were moving around the sun as opposed to all the planets and the sun moving around the Earth. In this very nice book called The Dialogue Between the Two Chief World Systems. So unlike the modern scientists who write who publish their findings, some rather boring scientific papers, people at that time were very interesting, had a very interesting way of communicating their findings. So Galileo wrote this book, very interesting book, which is actually written as a dialogue between two people who are making an arguments about two ways of explaining the observations. One is the traditional astronomer or philosopher who says that basically everything is moving around the Earth, while this new astronomer who claims this heliocentric theory of the universe, where all the planets were moving around the sun. And they basically put forward their argument, and there is a third independent referee who finally convinces that in fact all the observations seem to support, and logically also it makes sense that all the planets are moving around the sun. And Galileo's observations basically challenged the prevalent worldview of the things, and really put forward this intellectual movement called Enlightenment and the scientific revolution, and basically the beginning of the modern science is seen in these observations. And we know that basically all the modern technology eventually came from the modern science. But while the science and its huge influence continued over the last 3-4 decades, astronomers continued their own pursuit, which is to observe the universe and understand the universe. And one very important ingredient for improving our observations is to make bigger and bigger telescopes. The idea is that if you are able to, so Galileo's original telescope has a diameter of only 1 inch. So it can only collect so much of light. But if you are able to make a big telescope which has a large diameter, you are able to collect larger amount of light or larger amount of photons, and you are able to observe fainter and fainter objects or more and more distant objects in the universe. And one very pioneering person, astronomer, is William Herschel, and often his sister, who is Caroline Herschel, is also not credited so well, because we heard about this gender bias that exists in our world, unfortunately. So it turns out recently historians of science have recognized the important contribution of the Caroline Herschel, who was actually a sister of William Herschel, in making these large telescopes also. So here is a hand drawing of one of the largest telescopes that these Herschel siblings made, which had a diameter of about 50 inches. So it's one of the largest telescopes made in the history of the humankind. However, astronomers have been getting better and better at this. So the largest telescopes in the world now has diameter of about like 10 meter, which is like size of this, practically size of this stage. So, and this is one so-called the Keck Observatory in the Hawaii Islands in the US territory. We also have quite large telescopes in India. This is the so-called Himalayan Chandra telescope, which is located in Hanle in the Leh region, which is one of the largest telescopes in this part of the world. And astronomers like Professor Shivarani, who is going to speak after this, are involved in making even bigger telescopes. One is called the 30-meter telescope, which would have a diameter of 30 meters, which is basically bigger than the size of this whole hall. So you could imagine the kind of telescope these astronomers are building, and the kind of magnificent sciences that one could do by collecting these very, very faint glimpses of small number of photons coming from really the edges of the universe. At the same time, so you see this by looking at this the sky using these very large telescopes, astronomers have basically mapped the entire sky remarkably well. Here is one image showing how the sky would look to these optical telescopes. So you could see that there is this band of light which is basically coming from our own galaxy. Our galaxy has something like 10 to the 11 stars. So you get 10,000 crore stars in our own galaxy. And basically our galaxy, as you know, has a shape of basically a disk. It is a spiral galaxy. And since we are also part of this disk, we are seeing through this disk. That's why our galaxy appears as a bright stripe in a dark side. Unfortunately, it's not possible to see a sky in Bangalore, but maybe the lucky children of Kolar and other regions could see in a clear sky the galaxy as a bright strip. So basically, astronomers basically plot these stars in a particular coordinate system in which our galactic disk is seen as these x-axis. So basically, our disk of galaxy appear. The Milky Way is basically this bright horizontal axis that you see. But interestingly, the same person, Herschel, discovered one important clue of the nature of light. So now we know that light is just electromagnetic radiation. Our eyes just happen to be sensitive to a particular frequency of electromagnetic radiation, but light basically exists in an entire range of wavelengths or frequencies. And this is an experiment that many of you would have done in school. If you basically disperse the light using a prism, basically light gets split into multiple colors. It's so-called Vibgyor colors. And this is something that many of you must have done in class. But Herschel did something very clever. So this is this familiar Vibgyor colors, but he put a thermometer outside, even outside this red region here, which is nominally dark here. But after some time, he noticed that the thermometer is reading increased and increased temperature. And he concluded that there has to, just like if you put your hand in the sunlight, you will feel the heat. So basically, Herschel so that you actually feel the heat, but there is no visible light there. So he concluded that there is an invisible light there, which is similar to the other wavelength of light, which is something that we cannot see, and this is he called as infrared radiation. And this is an experiment that all of you could do in school. So if you create a cardboard box, put a slit, and then put a prism or a diffraction grating there, you would see this familiar vibgeo colors. But if you put a thermometer further down the red region, you see after some time the thermometer is increasing so you are basically discovering the infrared radiation. And in fact, these days it's very, very common, especially after COVID. All of us are using the thermometers, which are you can only touch. These are the infrared temperature thermometers, which basically measures the infrared radiation produced by our body. Which is our body is hot, and it is producing this infrared radiation. So now we know, as I said, basically light is an electromagnetic waves. Electromagnetic waves exist across an entire spectrum of frequencies or wavelengths. In the lowest frequency or the longest wavelength is basically the so-called radio waves, which are used for radio communication and so on. And the next shortest wave is the microwave radiation, which is used for mobile phones and so on. And then the infrared radiation, something that I just spoke about. And our eyes happen to be sensitive to a very narrow range of wavelengths or frequencies, which are micrometers of wavelengths, and because of some evolutionary reasons. And that's what we call visible light. And higher frequencies have ultraviolet and then X-rays, and the highest frequencies are called the gamma rays, etc. But basically, all these are different wavelengths of light. They are described by basically the same set of physical laws called Maxwell's equations of electrodynamics, and there is a quantum theory of it, etc., etc. But essentially, light is electromagnetic radiation of different wavelengths. And astronomers have been now quite clever, with the help of very clever engineers like the people in the UR Rao Satellite Center, have created these instruments which can detect electromagnetic radiation across all these frequencies. So here is a CAD drawing of the satellite called AstroSat, which is launched by ISRO a decade ago in collaboration with several research institutions in the country, which is a multi-wavelength satellite, observational satellite. Basically, it has one of the large, best telescopes for observing ultraviolet radiation. It has X-ray observatories, X-ray detectors, both in so-called soft X-ray and hard X-ray, as well as optical telescopes. Basically, so you are observing an object with multiple frequencies of electromagnetic radiation. This is a large radio telescope called the Giant Meter Wave Radio Telescope, located in Pune, which is operated by the Tata Institute of Fundamental Research, one of my home institutions. So you could see that this is a Tata Sumo, which is about 3 or 4 meters wide. So each of these dishes has about 30-meter diameter, and this GMRT contains an array of about several dozen telescopes, or 100 telescopes located in several tens of square kilometers in the outskirts of Pune. It's one of the largest radio telescopes that exist across the world. Similarly, this is an X-ray observatory called the Chandra X-ray Observatory, which is a NASA observatory, and this Chandra is named after S. Chandrasekhar, who is an Indian-American astrophysicist. Here is another a gamma ray telescope, and here is another microwave telescope, etc. So in the last several decades, astronomers have been observing the universe using all these very interesting instruments, which are able to measure electromagnetic radiation across different frequencies of the electromagnetic spectrum. And whenever they open this a new instrument that is observing a new frequency of electromagnetic radiation, they are surprised always. So here is an example. This is the same picture that I showed earlier. If you look at the sky using an optical telescope, you see basically our galaxy, a large number of stars, etc. But if you observe the universe using a microwave detector, which is basically similar to a detector that is used for our mobile phones, etc., you are seeing a very, very different phenomena. This is something called the cosmic microwave background radiation. This is produced this is the earliest light that we can see from the universe. This is produced over 13 billion years ago, just a few lakh years after what we think the Big Bang is. And wherever you look at the sky, you see this microwave radiation coming from. So it has a remarkably same intensity wherever you look. But there is a small minor fluctuations in the intensity of these radiation if you get different parts of the sky. So they are shown by these blue and slightly hot red regions. These are slightly colder and slightly hotter regions, or slightly more intense or slightly less intense region. And now we know, using our fundamental theory and observations, that these hot regions eventually became stars and galaxies, and these cool regions became the large intergalactic voids, the large empty spaces between galaxies. We have a theory, in some sense this is a baby picture of the universe when the universe was very, very young, and we now understand how the universe evolved from this baby picture to this current universe having a large number of galaxies and stars and planets, etc. Similarly, you look at some other part of the universe, for example, using X-ray observations, so our part of the electromagnetic spectrum, then we see a very different thing. So we are seeing these X-ray sources which are produced basically black holes accreting gas from the surrounding, and this gas gets very, very heated up and producing these X-rays. So my summary is that using these different wavelengths of electromagnetic radiation to look at the universe is like having different windows to the universe. Each window is giving you a very, very different picture and is giving you access to phenomena that we did not know that existed before that. So each telescope is opening like a new window. Interestingly, in the last 50 years or so, astronomers also have started using messengers that are different from electromagnetic radiation. Here is an example of what is called cosmic rays. Cosmic rays are not light. They are misnomer as a ray. They are basically small particles like protons or nuclei of heavy elements that travel very, very high speeds, travel as fast as the speed of light. They are extremely energetic. They are more energetic than the most energetic particle that we produce in the laboratories, like this Large Hadron Collider in Geneva. So these cosmic rays basically travel from very, very far galaxies and distances, and they hit the atoms on our atmosphere, and they produce a shower of secondary particles like pions and so on. And these produce, this is an example of what is called a cosmic ray shower, and it produces a number of secondary particles, and this can be detected using a variety of detectors. For example, water tanks. So when these particles pass through water, they produce a particular radiation called Cherenkov radiation, which can be detected, and there are detectors that detect these cosmic rays. In fact, some of the pioneering work in cosmic rays was done in our own country, in our own state, in Kolar, and I'm very glad to hear that there are schools from Kolar in this audience. So many of you know about this Kolar gold mines, and there used to be this very interesting experiment that is again run by the Tata Institute. They had this very, very deep mine, several kilometers downstairs, and some of the foundational discoveries of cosmic rays was done in the Kolar gold mines. Unfortunately, we could not continue this these experiments in the 90s and 2000s, so we could not be pioneer in we could not continue our pioneering discoveries in this field, but some of the foundational discoveries of cosmic rays actually happened in Kolar itself. And the current observatories, here's an example of this observatory in Argentina called Pierre Auger Observatory. These are has this large number of water tanks which detect these cosmic rays, and they have basically detected hundreds of such cosmic ray events, and this is a sky map of these arrival directions of cosmic rays, just like this plot that these astronomers were making. So each of these black dots are the arrival directions of each very extremely high energy cosmic rays called the ultra high energy cosmic rays. These are 1,000,000 times more energetic than the most energetic particles that we produce in these large hadron colliders. So there is some cosmic particle accelerator that is accelerating these particles to very high energies. We do not know what exactly they are, but we have been detecting them. So it's a new way of observing the universe that is different from using a messenger that is different from light, but this something called cosmic rays. Another example is neutrinos. Neutrinos also are subatomic particles, but unlike the proton, they have charge neutral. They have no electric charge. And in fact, they also interact very, very little with normal matter. So when I speak, when we are, trillions of neutrinos are passing through my body without me knowing. In fact, the sun itself is a very copious source of neutrinos. So we are producing it, trillions of neutrinos are passing through every square meter of our Earth produced by the sun itself. But there are much more energetic neutrinos produced by cosmic explosions like supernova explosions or spinning neutron stars like pulsars, etc. And there is this very remarkable observatory called IceCube, which is in Antarctica. So what they have done is to drill kilometers of, make these large holes in ice, kilometers deep, and put these photodetectors like cameras. And when these neutrinos pass through this ice is a remarkably transparent thing. And it produces this so-called Cherenkov radiation, which is detected using these very sensitive detectors. And here is the top of the observatory, but the actual detector is kilometers down, like 3 kilometers down. So similar, IceCube also has detected hundreds of such neutrinos coming from, and this is showing a sky map of these neutrinos coming from different part of the universe. Again, it is not entirely clear what is producing these neutrinos. They are producing more questions than answers. We have possible answers. It could be produced in supernova explosions, on spinning neutron stars, etc. But the jury is still out. And one remarkable thing about neutrinos and the light difference is that light is produced from the surface of stars, right? What we see when we see the sun, we are seeing the surface of the sun, while neutrinos are produced at the interior of the sun. Because of the nuclear reaction that happened in the interior of suns, neutrinos are produced. So if you want to see what is happening at the interior of the suns, neutrinos are the way to go. While if you want to see what is happening at the surface of the sun, that is, light is the way to go. So by combining these observations, we are able to gain more. We are able to see much more about the phenomena. This is called multi-messenger astronomy. You are studying the same phenomena using multiple observational messengers. The latest addition in the astronomer's toolkit of these multi-messenger observations is gravitational waves. So gravitational waves are something even stranger as compared to neutrinos or cosmic rays. They are also different from light. So they are basically freely propagating oscillations in space-time. So this is a prediction of Einstein's theory of gravity called the general theory of relativity. Einstein's theory says that gravity is not a force. It is a more accurate description is gravity basically bends space-time. Gravity curves over space, gravity affects the flow of time. Gravity affects the way the clocks would tick. And gravitational waves are basically disturbances that propagate in the space-time, called ripples in space-time. And whenever there is a very, very violent astrophysical phenomenon, like a merger of two black holes, it produces a large disturbance in the space-time that propagates the universe at the speed of light. And if you have a very sensitive instruments like the so-called LIGO observatories, we are able to measure these very, very tiny disturbances produced by the passage of gravitational waves. So here is an aerial photograph of the LIGO observatories in the US. These are these large L-shaped, what you call interferometers. And when these gravitational waves pass through them, they produce a minor disturbance in the space-time, which is very, very small, much smaller than an atomic nucleus. But using these very precise and sensitive instrument devices, you can measure these things. And this is what LIGO has done in 2015. We celebrated the 10th anniversary of the first detection of gravitational waves in the last year. So here is a signal, a gravitational wave signal that LIGO saw in 2015. And by analyzing the signal, we can conclude that the signal was produced by the collision, the merger of two massive black holes at a distance of about 1 billion light years, a very, very distant galaxy. And over this billion years, these gravitational waves have been propagating through the universe and reached Earth on 2015, September 14th. And of course, the founders of the LIGO observatories, including Ray Weiss, Barry Barish, and Kip Thorne, got the Nobel Prize in 2017 for decisive contributions to the LIGO detector and the observation of gravitational waves. And Professor Kip Thorne, we heard from Mr. Naidu, gave a lecture in Bangalore at ICTS in 2017, soon after the discovery, which was attended by 2,000 people, etc. It's a big event. So since then, LIGO has been detecting many, many new signals. And one very interesting signal was detected in 2018, which is produced by the collision of two neutron stars. Neutron stars are some very exotic stars which are produced by entirely of neutrons. And one remarkable thing is that we not only detected the gravitational wave signals from the collision of this neutron star, this collision also produced a flash of electromagnetic radiation. And it was detected by electromagnetic telescopes using gamma rays, X-rays, optical, UV, and radio over the entire spectrum of electromagnetic radiation. And so here is, for example, this is basically using the gravitational wave signal, we could say that the gravitational wave signal came from some part of the sky, and an orbiting satellite by NASA called Fermi detected a burst of gamma rays coming from the same patch of the sky. Then a large number of electromagnetic astronomers looked at this patch of the sky and found a flash, an optical flash, which is called a kilonova. And this was followed by a large number of telescopes, and they found basically an electromagnetic signal across the spectrum of electromagnetic waves. And it resulted in a very spectacular amount of science. It is too long to describe in one way, but in this talk, but I'll say two things. One, which are quite fascinating. One, it provides us this joint observation of gravitational waves and electromagnetic waves from one single source, enabled us a new way of measuring how fast the universe is expanding. I don't know how many of you are aware of this because of ChatGPT and internet. It must be very common knowledge. Our universe is not a static thing. The universe continues to expand. And we not only know that, the universe is expanding at a rate faster than yesterday, today. So the expansion is accelerating. And this requires a very mysterious energy in the universe called the dark energy. We do not exactly know what that is. But there is a lot of very, very precise observation that shows that the universe is expanding. But there are multiple very precise observations, but there is some discrepancy between the exact value of the expansion rate called the Hubble constant. So it is very important to have newer ways of measuring the universe expansion rate, and these multi-messenger observations of binary neutron stars will provide a new way of observing. And this was the first time we saw in 2018. Another fascinating topic is that how did these various elements, especially the heavy elements in the universe, come out? So again, many of you must have heard that most of the elements that we know, like up to iron, including carbon, our body, hydrogen, etc., are produced hydrogen is produced in the early universe itself, but the carbon, etc., is synthesized in the interior of stars. But how did the heavy elements like the gold in our hands, if you have a gold ring they cannot be produced in the interior of stars. So where did these heavy elements come out? It turns out that these explosive stars like supernovae or the merger of neutron stars is one region where these heavy elements are synthesized in the universe. And there is a very interesting estimate that a single merger would have produced an Earth mass worth of gold. There is a gold ball which is as massive as the Earth is produced in one merger of neutron stars. So the world is very expensive, as you can know. So maybe, but unfortunately it is about, you have to travel about 100 million light years to reach this merger. So it is unlikely to happen in your own lifetime. People like Professor Shivani, it's a much more harder question to ask, but for people like Professor Shivani asking these very, very important questions, and they are uncovering several layers of details of these questions, and we are very happy to contribute to this particular discovery, this particular question by observations as multi-messenger sources. So in the last 10 years, LIGO and Virgo have observed about 300 gravitational wave signals from such mergers of black holes and neutron stars. This is one way of representing all these signals. Basically, these are all the black holes that are discovered through gravitational wave observations in the last 10 years. So until now, we had some indirect way of observing black holes from our own galaxy. So this is showing the mass of these black holes in this vertical axis. And all these blue dots are these new black holes discovered by gravitational wave observations in the last 10 years. And while all these crimson dots are the black holes discovered by electromagnetic observations from our own galaxy. So we are discovering new populations of black holes using these gravitational observations that we did not know to exist until then. It's really opening up this new branch of astronomy. And in the last 10 years, we detected about 300 gravitational waves, but in the next 10 years, we will be detecting tens of thousands of new gravitational waves. So if I'm lucky to be invited to a National Science Day event after 10 years, I will come back hopefully and tell you that we have discovered not 300 gravitational waves, but maybe 300,000 gravitational waves. So that is the range that, or my next generation colleagues would come and say this. That is the rate which these new frontier of astronomy is exploding. So one very interesting thing about these gravitational waves is that gravitational wave observatories are sort of omnidirectional instruments. So I'll conclude in the next 2 minutes by telling something very exciting happening in India at this point. Gravitational observatories are basically nearly omnidirectional antennas. We are able to, using a single detector, we are able to detect gravitational waves coming from any part of the sky. It's actually very good because unlike a telescope, we don't have to point to a particular location. So if you have one detector, we can detect gravitational waves coming from anywhere in the sky. But it's also not a very good thing because we cannot exactly tell where the signal is actually coming from. And that is achieved by using a network of detectors. So if you have detectors at multiple parts of the globe, these gravitational waves would come at one detector first and another detector later. So by looking at the time delay between the arrival time of the signals, we can triangulate the source in the sky. This is exactly how our ears work. That's why we have 2 ears. Because if you have closed one ear, you cannot tell where the signal is coming from, the sound is coming from. We know the sound, if the sound is coming from this side, it will reach my right ear first and then go to the left ear. There's a small time delay. And our brain is able to process this time delay and able to localize the source of sound here. It's exactly how gravitational waves detectors work. And that's why we need to have a network of detectors. Currently, there are 2 detectors in the US called the LIGO. There is one in Italy called Virgo. There's a smaller one in Germany called GEO. There is one upcoming in Japan called the Kagra. But most importantly, there is an upcoming LIGO detector in India called the LIGO India, which will be located in Maharashtra in the Hingoli district, which will significantly improve our ability to localize the sources in the sky. And I am particularly glad that LIGO India is finally happening. This is a news from the Nature magazine last year, where India was basically floating the tenders. But 2 days ago, if you are following the newspaper, you would have seen a news item that basically the construction tender has been issued, and this company called L&T got this tender, etc. The construction for the LIGO India is formally going to happen in the next few months, and hopefully it will be completed in the next 5 years. This is a CAD drawing of this LIGO interferometer that will come up in the Hingoli district, which would be, as we see in this news item, which will be one of the most sensitive listening posts in the universe. These are the most sensitive measurement devices the humankind has ever constructed, and we're detecting these millions of gravitational waves in the next 20 years. And one very interesting aspect of these detectors, that these are extremely sensitive detectors, as I mentioned earlier. It requires a combination of very deep fundamental physics, technology, engineering, and signal processing. So there is there is an ability for all of you to contribute, a possibility for all of you to contribute to a project like this using multiple ways. If you are a very good engineer, if you are a very good scientist, if you are a very good data processing person, if you are a very good computer scientist, all of you have a role to play in a frontier project like this. And I'm hoping that many of you will be inspired to contribute to this endeavor in the coming decades. So let me stop and summarize. Modern astronomy began about 400 years ago because of the discovery of the telescope by Galileo. But in the last century, astronomers have been building extremely large telescopes, and more importantly, expanding, creating instruments that are able to observe electromagnetic waves across the spectrum of electromagnetic radiation. And recent discovery of gravitational waves by LIGO and Virgo have opened up a new branch of astronomy using the observation of gravitational waves. Hundreds to thousands of new event signals are expected in the next few years. And the next 10 years, next decade, we will be observing tens of thousands of new events, which really opens up a new branch of astronomy. And I did not tell you this one. There are also ongoing projects to build gravitational detectors in the space and the moon, etc., which will basically start probe the entire spectrum of gravitational waves. Just like electromagnetic waves, gravitational waves also exist in an entire spectrum of frequencies, and astronomers are also starting to probe these different frequencies of electromagnetic spectrum. And it's really beginning a new branch of astronomy and a new window to the universe. So let me stop here, and thank you very much.
Thank you, sir. On behalf of the entire URSC community and the audience present here, I extend heartfelt thanks and deep gratitude to our respected chief guest, Professor Ajit Parmeshwaran, for kindly accepting our invitation and gracing this occasion with his esteemed presence. Now, I invite Director URSC to stage. Now, we would like to thank our chief guest with a memento. I request Aarti Gupta to please assist the director. I request Director URSC and Chief Guest to kindly take their seats off stage. Today we feel honored to have with us our guest of honor, Professor Sivarani Tirupati, Dean, Faculty of Sciences, Indian Institute of Astrophysics. As I welcome you, we comply to the theme of this year, ma'am, Women in Science Catalyzing Viksit Bharat. I now request Ms. Nagashishi Devi to kindly introduce the guest of honor to the audience. Ma'am, please.
Very good morning all. It is my pleasure to introduce Professor Sivarani Tirupati, a senior professor at the Dean Faculty of the Indian Institute of Astrophysics in Bangalore. She completed her PhD in physics from the Indian Institute of Astrophysics in 2000. Before joining IIA, she has held several international postdoctoral and research positions at CNRS in France, INF in Italy, Michigan State University, and the University of Florida. Her primary research focuses on stellar and galactic archaeology, exoplanets, planet host stars, and instrumentation. She studies ancient stars in the Milky Way to uncover the chemical imprints of the first massive stars and supernovae. Dr. Tirupati is a highly accomplished academic with 115 publications in refereed journals and over 18,000 citations. She also holds several notable leadership roles in the astronomical community, including the Vice President of the Astronomical Society of India. She is an architect of the SDS's Marvelous Exoplanet Radial Velocity Survey, member of the Scientific Advisory Committee of the upcoming 30-meter telescope, Hawaii, and the principal investigator for the 30-meter telescope high-resolution optical spectrograph. Please join me in warmly welcoming Professor Sivarani Tirupati, a leader shaping of the future modern astrophysics. I request Professor to deliver the talk. Thank you, ma'am.
Yeah, it gives me a great pleasure to be here. First of all, I would like to thank our URC director for this opportunity and the organizing committee. And really, it's an honor to be here in front of the young minds and being part of this very interesting event. I'm really pleased to be part of this. So I would straight away start this talk. Actually, so it covers two different aspects. One is the stellar fingerprints. It's one of the oldest part of the astronomy. Studying stars is one of the oldest branch of astronomy. And then New Worlds is the exoplanet studies, which is just started only about 20 years ago. So I chose this topic because it covers some of my expertise. I would go through some part of our history so that just to give a glimpse of how the field evolved. So yeah, So this is, so we all know that stars are actually hard ball of gas. And in the centers of stars, we have nuclear reactions happening where two hydrogen atoms, nuclei join together to make helium nuclei and generating energies, and they continue to glow. So what are the stellar fingerprints? Like I think Ajit already introduced. So when you look at the sky, like on a rainy day, you would see a beautiful rainbow. Basically the light coming from the sun, it's dispersed through the water droplets, and you would see a beautiful rainbow. And if you look at the rainbow in very detail, like if you are able to see it very carefully with a instrument, you would see dark bands, like what you, okay, I think, yeah. So these dark bands, what you see in this picture, actually is drawn by Fraunhofer. You would have studied in your school Fraunhofer lines, Fraunhofer spectra. So these are the dark lines which actually some of the atoms which are present in the outer layers of the sun, they absorb these particular frequency because the electrons move from one level to other by absorbing certain frequency of the light which is coming from the interior of the sun. So these are characteristic signature of a star. So we call it a stellar spectra, and I kind of referring to it as a stellar fingerprint here. So this is the actually original drawing by Fraunhofer. And this is again an illustration to show in a detail these dark lines. So he has ordered it like ABCD in terms of various line strength and how strong, how darker the line. So he has made it a list of ABCD. So you would have been familiar with the sodium D line, like which is a sodium vapor lamp, or in the experiments in the lab you would have seen. So the D comes from the way they ordered the naming the spectral lines as ABCD in terms of. So now we know that A and B are actually not from the sun, they are the earth atmospheric lines. These are water vapor lines from the earth itself. So if you look at different stars, so their fingerprints look very different. There are different dark bands. You can see like, so hotter stars have a different kind of lines, and cooler stars have different kind of lines. So these beautiful ordering actually happened by the effort of who we call as one of the pioneer in spectral classification. She is Cannon, Annie Jump Cannon. So she took painstakingly, she looked at spectrographic plates. So these are actually spectrographic plates where what you see, this dashed lines are actually spectra of small stars, like individual stars. Each dash represent a star, and the light from the sky goes through the light that is collected by a telescope goes through a prism, and it is recorded in a photographic plate. So these prism disperses the light, and you would see these dashed lines. So she looked at it carefully and classified more than 350,000 stars, and finally arranged them in terms of their like ordered them as O, B, A, F, and later we know that these are actually forms a sequence of temperature. But until when she was doing it, it was not aware that it forms this temperature sequence. Now we further know there are more classes like what we call as L, T, and Y dwarfs. So these are brown dwarfs, they are not stars. They are not hot enough or massive enough to fuse hydrogen in the center. So some of them fuse deuterium. So that's the major difference between planet and brown dwarf is brown dwarfs fuse deuterium inside the atmosphere, inside the nucleus, but the planets are not so massive to fuse deuterium. So that is the where we define the boundary line between an exoplanet and a brown dwarf. And this is again to show this spectral lines. So what is a first impression for anybody, like when early days people looked at it, the strongest line, this is a spectra of the sun. You see a lot of absorption bands. So these are the dark bands what you see. and they are all coming from various elements. So you can see calcium, magnesium, and and iron. So people thought actually the sun would be very similar to our earth composition, because we all know earth has a lot of silicates. You see sand everywhere and you see iron. So we know iron core forms the earth. So it was expected that sun should have very similar composition like our earth. But until we have a brilliant thesis work by who we call as Cecilia Payne. So she worked at the Harvard College Observatory, and as part of her thesis, she analyzed the spectra of our stars, and she said most of the she found that the major composition of the sun is not actually iron or metals. It is more than 90% is composed of hydrogen. Hydrogen is the dominant composition of sun. So this was kind of, at that time people didn't believe. So they asked actually to rewrite her thesis, saying that maybe soften it down and say that maybe it was an error in the analysis, could have led to the fact that she has come up with the conclusion that hydrogen is the dominant composition of the sun, but whereas it could be likely it is wrong, because we know earth has all the silicates. But so she is actually, she's a very brilliant, like just 4 years before her thesis, one of the well-known scientists, like an Indian physicist, Meghnad Saha. So he has done, he has come up with this theory of ionization equilibrium. So she used that very cleverly to come up with the measurements or analysis showing that hydrogen is the dominant component of the sun. So later we all know that universe, including sun and most of the stars, have hydrogen as the dominant component. We know in the universe as well as most of the stars have 90% or 92%, or actually sun has 92%, and the older stars would have even more than sun. So hydrogen is the dominant component of our universe. So that actually laid the foundation of stellar spectroscopy, and this is an illustration to show two stars. One is one is our sun, which is shown in the red, and blue, which is the hottest and brightest star on the sky. So both are having same composition, but you see the spectral lines look very different, because it is the temperature and the ionization is different. That gives the stellar fingerprints which are different. So just moving on to this, so this actually the work by Cecilia Payne made the foundation for chemical evolution or chemical history of the galaxy using stars. So so in this work, I just wanted to show this is the spectra of sun. You can see a lot of absorption lines of iron, nickel, and various elements, but you can see stars which have very fewer lines. So these are called what we call as metal poor stars. So as we know, when the universe started, as in Professor Ajit's presentation, universe, when it started with the Big Bang, we had hydrogen. The hydrogen nuclear reaction, Big Bang nucleosynthesis had formed hydrogen by combining proton and neutron, and then we had helium nuclei by combination of fusion of two hydrogen nuclei. But further, the universe couldn't form further could not build bigger nuclei, because the universe was expanding faster, and also there is, to form carbon you need 3 helium nuclei, because the density was low, so you couldn't form further nuclei beyond helium. So lithium is a trace amount of lithium is also formed during Big Bang nucleosynthesis. So all the elements beyond lithium are formed in stars. So this is actually laid the foundation of what we call as stellar archaeology. It's a field which I'm I work on. So it helps us to trace back the history of our universe by studying stars, and we can trace back what was the first stars which were formed in the universe. If they are still present in the Milky Way, we could study them in detail. And like whatever Ajit was telling, like I wanted to show that these are the two stars which are showing, like one of the star has a rich abundances of all the rare earth elements, like you can see samarium, erbium, cerium, barium, and so many elements. And these are two stars of very similar temperature, but one is enriched in these heavy elements, another one doesn't, it's not enriched. So this gives a direct signature of an event like a neutron star merger event, which had produced various R process or the rare earth elements including gold. So we have these metal poor stars which have directly record the events, early recording of the events due to a supernovae or any energetic explosions. So just moving on, like these metals actually formed a very important aspect for planet formation, because metals are key ingredients for, sorry. So as Ajit was telling, like our entire body, the heavy elements, what we, carbon and calcium and oxygen in our blood and everything has to come from stars, because none of them is produced during Big Bang. So we are actually composed of stars material. So these heavy elements are actually the life ingredient. So as we move on, like we also see that exoplanets in outside solar system, we find stars which are metal rich tend to possess planets compared to stars which have lower metallicity. So this field started in 1995 when the first exoplanet was discovered around a sun-like star by Michel Mayor and Didier Queloz. So this is, again, this particular star is also metal rich compared to our sun. And yeah, so what we see is, like now, starting from 1995, now we know about 6,000 planets around various stars. And but if you see this plot, like these represent our solar system objects. Like all the planets so far discovered are all nothing close to our solar system. So it's partly due to our sensitivity in detecting these planets, and another thing is, even within this limit, we don't have any of these super Earths and mini Neptunes which are shown in this graph. So none of them are present in our solar system. So it is a new revelation that whatever we see, what is the dominant planets which are seen in outside solar system or the outside our sun, like in other stars, none of these dominant super Earths and mini Neptunes which are found in many stars, nothing is found in any of these our 8 solar system planets. Nothing is very similar to them. So this is again a plot showing actually like Kepler's discovery. Like what you can see that this is a solar system like these, and you can see that all the planets around the stars are rotating so close, they are orbiting very close to the host star, whereas our solar system is much bigger than any of the planets which are discovered. So this is again, we all probably might have learned this from the ChatGPT or seen. So the way people discovered even the first exoplanet that was discovered by Michel Mayor and the collaboration is through the radial velocity method. When a planet goes around the star, both the star and the planet moves around the center of mass, but planet is not bright. Planet is a cold object, star is like our sun is 5,800 Kelvin, but a Earth-like planet will be just like we know, like it's 35 degrees is Earth temperature. So we wouldn't be able to measure the light coming from a planet. So one of the ways to actually detect is the wobbling motion. What you can see, that the star is also moving around the center of mass at a slow speed. So this, by measuring the spectral line, whatever you know of Doppler shift, like when the object is moving away from you, the spectra shifts towards red, and when it's coming towards you, it moves towards blue. So this spectral line shift is called the Doppler shift, and this is the signature we look for to measure to detect and measure the presence of exoplanets and also measure their masses. And if we have to actually detect a planet like Earth around another star like our sun, we have to measure velocities like 10 centimeters per second. We have to, so it is like a crawling baby, basically a star that is moving at a speed of a crawling baby. We have to measure that through our telescopes, the shift in the spectral lines. So this is very, very challenging, and there are different, and adding to that, there are also other difficulties. We know our sun has sunspots. So sunspots are coming from convective motions. Convective motion is the plasma in the surface of the sun is moving around, and any motions will contribute to shift in the spectral lines, similar to your exoplanets. So that further plagues the signature what we have to see. So it is, but one way to detect is the time scales are very different. The convective motions on the sun are of the order of minutes to days, and whereas the planetary signal is about a year. So we can differentiate the signal that are coming from like the stellar activity or stellar granulation and convection compared to a planet that is moving around the sun. So to actually measure such shifts, so this is actually in, so the light is captured by a telescope, and at the focus, the light is collected by a fiber, optical fiber, and fed to a spectrograph. And in the spectrograph, we try to find out the shift in the spectral lines. But we all know, like when light goes through any medium, it bends because of the refractive index. But if your spectrograph, if it is kept at if the temperature of the spectrograph varies, your glass temperature would vary, hence your refractive index of the glass or prism what you use in the spectrograph also changes, and that also causes the spectral lines to shift. So you have to keep the spectrograph at very constant temperature, and also it is kept in the vacuum. And this is a spectrograph at the Himalayan Chandra telescope, but this is not a precision spectrograph in terms of radial velocity. Just you can see various components of the spectrograph. That's what I have tried to show. You have slit, collimator, grating, and prisms and everything. And this is the actual spectra taken from this Hanley-Eschel spectrograph, and you can see two lines. So several lines are seen. The broad lines are from the star, and there are tiny lines which are the calibrations. Basically, you want to actually have a lab reference to identify the spectra. So for now, people use what is called the laser combs to actually precisely know what wavelengths in the camera you record the spectra of the star and a calibrator lamp. So there are at PRL Ahmedabad, we have I think it's also part of the ISRO comes under DOE. So we have a Paras spectrograph which is kept inside a vacuum, and the temperatures are maintained at millikelvin level to maintain the stability, so that our instrument doesn't shift the spectra. It is whatever we want to measure is the spectra that is shifted due to the planetary motion. The star is moving around the center of mass. That is what we want to detect. We don't want the instrument to move. So it is very challenging to build such instruments, and the current record holder or the precision what we have is about 20 centimeters per second is what is achieved, but this has to be maintained for over 1 year or 2, so that we can detect the entire radial velocity, which is again a challenging aspect. Another method is the transit method, which we all familiar, and this was first planet using this method was detected in 1999, one of the brightest stars. And this is basically you detect the small dips when the star, the planet is moving in front of the star, you would see it blocks part of the planet's star's disk and causes a dip. So this is, if we have to detect actually a Earth-like planet around a sun-like stars outside beyond our sun, then what the precision what we need is we have to detect like something like 80 photons per million. So if you have recorded 80 like 1 million photons from your star, the 80 is correspond to your planet's dip. The dip correspond to just, so that is like 0.007% or so. So it's it's very challenging. The reason again why it is challenging is also due to the spots that are present in our own sun, and on top of it, if we have to detect these kind of planets using the Earth observations, the telescope which are on the Earth, what you would see is the light when you have pointed a telescope towards a star, the atmosphere we all know about star twinkling. The twinkling is basically the turbulence in the atmospheric, in the Earth atmosphere, which kind of changes the direction of the light that is coming into towards your line of sight. So what happens is this turbulence actually doesn't let, if fewer photons, if you don't receive in your line of sight towards your telescope, some photons gets away from your line of sight, then that also causes the loss of photons, which will mimic your planetary signals. So actually it's very important to detect Earth-like planets. We have to go to the space. So and ISRO is, I think, planning. So this is just to show a comparison of what we can achieve from ground and the space. So we can see two comparison of a James Webb telescope, which is a 6-meter space telescope, and we can see the spectra of a planet. It's a hard Jupiter. It's basically a Jupiter which is very close to the host star, and this is again from the ground, but it's a 8-meter telescope on the ground. But we can see the 8-meter telescope is more noisier than the 6-meter telescope in space because of the atmospheric turbulence and various noise sources which are plagued in the Earth observation. So another method which is called the direct imaging of exoplanets. So this is basically like if you have planets which are further from the star, you can block the star light, and so this what is shown here is actually the central star is blocked, and the spots that are moving is the planets. This is one of the famous planets which is have 4 planets actually. One of the methods to remove this noise around this is what is shown here. So you can focus on these 2 circles. One is the green and the red. The red is the actual planetary signal. You would see that the planetary signal would stay the same. So this movie is actually going for different wavelengths. So you are imaging at different wavelengths, and you see the planet signal stays at one place, whereas the green, the spot around green, it keeps moving away. So that is actually a speckle pattern, which is basically a residual diffraction pattern. So which is depends on the wavelength. So you can, the diffraction, we know that diffraction, you would have studied the maxima and minima, which depends on the n lambda. So the diffraction pattern, the residuals, actually changes with wavelength, but the planetary signal will remain the same at the same position. So that is one way they remove the systematics that is coming from these residuals. So I also want to show that we also have at Indian Institute of Astrophysics, we have built a direct imaging instrument for the Keck telescope, and which is going to be commissioned in the next 2 months. So that will be having the ability to actually image Jupiter-like planets around stars, which are about 100 AU away. So this is again an exciting thing which we are looking forward to. And so the future missions for the which have been in process, or it is still under debate, is actually to directly detect Earth analogs, basically Earth around a sun-like star. So that mission is called the Habitable World Observatory. So where you have a 6-meter telescope, similar to our JWST, but it uses UV and optical region, and the central star you have to block. So there is this is what the star shade is. So this is what is an occulter which blocks the starlight and allows the exoplanet only to come through the telescope. So you have to, it's a kind of a flight forming thing, and you have to precisely position that. So it's again a challenging mission, and this is where the field is moving. And as Ajit said, we are also part of India is part of the 30-meter telescope project, and IA is one of the coordinating institute. And you can see there are many women who are part of it. And at Hoskote, we make the mirrors for this 30-meter telescope. So the 30-meter telescope, it's very huge, like you can, it's bigger than, it's about this size. And so they are formed through 1 meter hexagons, and you connect several 492 hexagons to make a 30-meter telescope. So this is the polishing facility is at Hoskote, where so we have successfully polished, and this is the team. And this is one of the roundels which are polished at the Hoskote facility. And this is, I just wanted to show the, you can see the, like we also want to study the stars, because as we know the stars better, we also know the planets better. So this is one of the data I'm just showing on the right, is the data from the Aditya L1, which is ISRO's mission, and VLC is one of the payload which was contributed by IAA, and the data looks really, really nice. And I also wanted to show what is expected in the future. I think maybe it's, I don't know how accurate this is. There is a plan, I think the director can actually tell whether it's the current status is the correct thing. There is, as the community, the astronomy community is looking forward for a dedicated exoplanet mission. I think there is some talks going on. I think it's in a stage of, in the process. So again, the women who are leading the missions, and this is a very ambitious mission, because you know that you have to keep the star at a, if you want to, any loss of light, like tens of photons out of your million, if it is lost due to a jitter, you can't detect planets like Earth. And so just to summarize, like we talked about the history of astronomy. Mostly astronomy started as an empirical science rooted with careful observations of stars and sky, but later it moved on to combining, explaining the astrophysical processes through physics. But now it's really an exciting time, because astronomy actually is laying the foundation for physics through, that is something which is very different how astrophysics was looked at. So it's an era, really exciting era for physicists and astronomers to be part of this, part of actually doing astrophysics. And so with this last one slide, I'll stop here. So what I want to say is be curious in whatever we do, because as we saw, like some of the astrophysicists who looked at the spectra, it was a time-consuming work, but they still were curious and they were able to actually produce results which were really like changed the way we thought about the composition of sun and things like that. And so question what you don't understand and trust your reasoning. I think I wrote resonating. Yeah, so because always you are judgmental, because your logic, you have to convince yourself. So with this I stop. Thank you for your patience.
Thank you, madam. Thank you, madam. Your words of wisdom and encouragement have truly inspired the students and everyone present here. The thought-provoking address will surely guide us towards growth and excellence. Now I invite Director URSC to stage. Now we would like to thank our guest of honor with a memento. I request Director URSC to please present the memento to our guest of honor. I request Shri Prasad BS to please assist. I request all the dignitaries to please be on the stage. I would like to call our chief guest of the event and chairman NSD 26 to join dignitaries on the stage. Meaningful interaction, whether human to human or user to product, is fundamental for connection, understanding, and success. Let us begin our session, Interaction with Students, where our esteemed dignitaries will be answering the questions asked by the students present here. There are some volunteers present near you. You can just dodge a question to our dignitaries. The session will be for 5 minutes.
Hello, sir. Hello, sir and ma'am. How do you become a scientist at ISRO?
The question is, how do you become a scientist at ISRO? Yeah.
Study well, get your degrees, and come and join ISRO.
So, my question is, how are cosmic rays formed? The cosmic rays.
How are cosmic rays formed?
Yes.
Yeah, it's a good question. We don't know the full answer, but there are many possibilities. One is, there is this process called shock acceleration. So these cosmic rays are charged particles, and they can be accelerated by a process called shock acceleration. So there are some dense and less dense regions that are propagating. This can happen through some things like a supernova explosion or a black hole accreting. But the final details are still not understood. We are still figuring it out, but there are basic understanding of these mechanisms.
Sir, I have a question. Like, can a black hole swallow a neutron star? Like, it's a question I always wanted to ask my parents, but they never told me the answer.
The question is, can a black hole swallow all the stars?
No, a neutron star. A neutron star.
Okay.
It can. So if the neutron star goes very close to the black hole, it can swallow. But it can be slightly more complicated. What happens is that if you have a neutron star, one side of the neutron star gets a larger gravitational force as compared to the other side. So it get a tidal stretching. So just like, for example, the moon is creating the tides on the earth, the earth gets deformed into an ellipsoid, right? The same way the neutron star get deformed. In fact, in the case of this black hole, the tidal forces are so strong that it can basically stretch the neutron stars to large lengths, that only part of the neutron star would fall into the black hole, and other particles get ejected outside. And this is where we think a lot of these new elements are formed. People like Shivarani study them.
And so one more question, can black holes swallow gravitational waves? Can they capture gravitational waves and just like...
Oh, black holes can also catch some of the gravitational waves, but not everything, because gravitational waves are produced outside the black hole. Some gravitational waves would fall into the black hole, but some gravitational waves would go out also.
Thank you, sir.
Good morning, sir.
What is the future of implementing AGI system in space technology? What is an AGI system? Artificial intelligence.
Sir, artificial general intelligence. So it is said that it could become a threat to humanity because it has the capacity to exceed human knowledge and cause intelligence explosion. So how can it impact space science, and especially how can it impact ISRO and India as a whole?
So in general, artificial intelligence is not used in space technology for one reason, because artificial intelligence is not deterministic. That is, if the initial conditions are specified, how it leads to the final outcome should be theoretically explainable. That is what is called deterministic. Artificial intelligence, how it comes to a conclusion is till now most of the times is not explainable. How it comes to a conclusion or does any outcome it comes out of it is not explainable. So such systems are not allowed to be used in space systems, but they are all used on the ground to analyze the data that comes from satellites or other even science telescopes and other things. So these are mainly used for analysis of the data, optimization of various, when you have to analyze a million possibilities, it is easier to do with artificial intelligence. Whereas if something is going to be critical for the safety of the mission, then deterministic things only will be used. But all this will change over a period of time because artificial intelligence itself has come over last 2 decades only. So it is possible in the future it may get implemented.
Sir, my question is for Ajit, sir. Sir, as you mentioned about neutrons and all, right? There are other subatomic particles like antineutrons and antielectrons. How they are different from the neutrons, and why do you don't prefer them to study? Or
How antineutrons are different from neutrons?
And antiparticles are, counterparts of usual particles, but they have a different electric charge. For example, electron has a counterpart called positron, which has a same mass but a different electric charge. But it turns out, for some reason, that the abundance of antiparticles is much less than the abundance of normal particles. Again, the answer is not entirely clear, but the universe happens to be that way.
Sir, my question is to ma'am also. As you mentioned about star scheduling, right? As we know, the celestial bodies are huger than our imaginations. How we can do star scheduling for such a huger bodies?
Can you repeat the question again?
as you mentioned about star scheduling, right? And we are aware of the celestial bodies are huger compared to our imaginations. How we can do star scheduling for such a huge bodies?
Star? Star shaping for huge bodies.
Star scheduling, what we plot the light coming from the star and study the.
Okay, you are talking about the star shade.
Star, okay.
The direct. Okay, so basically, like you have to. This is for directly imaging the planet, Earth-like planet around a sun-like star. So because Earth is like 1 AU away, so it's very close to the star, and you have to block it, block the starlight very accurately. Yeah.
When you are out in the sun, how do you protect your eyes from sun? Just with your hand very close to your eye, you are blocking sun fully, isn't it? Your hand is so small compared to the sun, isn't it? So if you are keeping the blocking thing very close to your aperture, then a big thing can be aperture. You keep a small stone in front of your eye, it will block completely the vision. Whereas the stone, if you move away and away, this will block lesser and lesser, you will be able to see many things. So that is the principle. When something is very far away and the blocking thing is very close to the observing telescope or eye, it can block anything.
Sir, I have a question.
We'll take one last question, please.
What will be the exact definition of antimatter or dark matter in space?
What is the exact
definition of antimatter and dark matter in space?
Antimatter and dark matter are different things. Antimatter is something that I said. Usually you have the standard particles like electrons and protons, and there are particles which are exactly the same for other properties except for the electric charge. Those are called the anti-particles. Dark matter is something different. So we know from various astronomical observations that galaxies and other astronomical systems contain a much larger amount of mass as compared to the stars and the usual gas in this one. Because we see the gravitational effect of this matter on other objects, like luminous objects. If you look at the motion of stars, etc., if you want to explain their motions, there has to be a larger gravitational force. We don't see this using electromagnetic observations. We don't know what kind of particles that they are. They could be some fundamental particles that we are not known in this so-called standard model of particle physics, or they could be other things like black holes and so on. That's a dark matter.
Sir, I had a doubt. We have been learning in schools that gravity is a force. So I couldn't quite grasp the concept of gravity existing as a wave.
Gravity is not a wave, but gravity produces a wave as well. It is the same wave. For example, we know the electric and magnetic fields, right? But the electromagnetic waves are variations in the electric and magnetic fields that are freely propagating. In the same way, the freely propagating oscillations in the gravitational field is the gravitational wave. So gravitational wave is a wave associated with the force of gravity. But a better description of gravitational force is the space-time curvature. That's why we call gravitational waves as disturbances in the space-time curvature.
Okay, we'll close this session now. I request all the dignitaries to please be present on the stage. As we all know and believe that recognition is the most powerful motivator and a little whisper which says keep going. It is now time to recognize the knowledge, talent and hard work of the winners from various events organized on account of National Science Day 2026 at URSC on 21st of February 2026. So now I request Shri Anant Shayanam to please commence the prize distribution.
Thank you, Rupali. It's my honor and privilege to announce the prize list for NSD 2026. There's no doubt it was a very tough competition and they were very energetic and there is a lot of participation. So our judges took a time to announce the prizes, and a big round of applause to all the participants and winners. So let's begin the prize distribution. The brief events conducted were model making, extempo science elocution, science in action, science quiz, spot painting, teachers incitement, test of scientific temper. So a small announcement here. If any winner is not present here, the student or teacher of the respective school can receive the prize. All the winners are requested to please come from the left side of the dais in the ramp to take the prizes and leave the stage from the right side of the. And I request our dignitaries to do the honors of distributing the prizes. And I request Director URSC to share, Shankaran sir, to hand over the prizes to them. For model making in the category B, first place goes to Vagdevi Villa School, Varturu. Students' names Arsha A, Vishrut A, Mihir Kumar Jha. Second prize goes to Vagdevi Villa School, Nelamangala. Sajid Gowda AG, Samyak P. Shanbog, Samrudh M. Third prize goes to again Vagdevi Villa School, AV, Nidish Sunku, Sannepalli Venkata Navadeep, M. Santosh. The first consolation prize goes to NPS HSR layout. Arshit Kevalni, Utkarsh Gupta, Arin Bharadwaj. Second consolation goes to Shujugrah Montessori and High School, Tejas Kunat Menon, Bhavish Nagaraj Reddy, Sagun Shahu. Yeah. For the next category, model making in category C, the first prize goes to Prashant Central School, Shujan V. S., Ashavardhan Gowda, Sanket B.S. Yeah. Second prize goes to KK English School, Prajwal Kumar M, VM Sai Charan, Murugudu Samant Venkatas Datta Sai. Third prize goes to NPS HSR, Niranjan Satish Chandra Rao, Om Sujay Bendre, Rishan Chattopadhyaya. First consolation, BJS World School, Pratik P. Gagan R. Shayank Survamshi. Second consolation goes to Vijay Sardar Patel High School, Vijay R. Achar, Vishnu Kaundinya, Kritav SB. Thank you. Now, for the event of science quiz in the category C, BGS National, the first prize goes to BGS National Public School, Nihal Patel, LAT, Vishank Naman, Rishabh Hiramat. Second prize goes to New Horizon Gurukul, Shishir Ittori, Sarthak Niland, Geetang Kumar. Third prize goes to NPS HSR, Niyant Mukundan, Ashwin G. Rao, Pranav Srikanth. Consolation 1 goes to Global City International School, Kirat Singh Pongila, Aradhya Anant Upadhyaya, Yasneni Tiwari. Yasnil Tiwari. Second consolation goes to New Horizon Public School, Abhinav Y, Amar Ashish Patro, Sudarshan S. Next. Third consolation goes to InVenture Academy, YRP campus, Anish Patel, Nirav Ratwar, Pranav CS. Now I request our chief guest, Professor Ajit Parmeshwaran sir, to give the prizes to the students. In the category of scientific temper, in the category C, Vagdavi Villa School, Varturu, Emin Dalal, Omkar Shashidhar, Mahapati Himanshu Sachin Bande. Second prize goes to Kendriya Vidyalaya NAL campus, Shravya Tiwari, Shivansh Verma, Divyansh Srivastava. Third prize goes to National Public School HSR, Siddharth OAT, Viman Barnwal, Salma Radhakrishnan. Okay. First consolation, Presidency School of Kasturi Nagar, Viraj Gupta, Aditya Natarajan, Kavya Sharma. And second consolation goes to VVS Sardar Patel High School, Bhavan N. Keshav Arvind Ishan C. Hello sir, late ಆಗುತ್ತೆ. Yeah. Now in the category of spot painting, in the category A, HAL New Public School, Adit Gautam. Okay. And I request all the students to sit.
All the students are requested to please be seated.
Second prize goes to Presidency School, Kasturi Nagar, Divit Nagappa. Not there? Yeah, not there. What happened? Third prize goes to BGS National Public School, Charvi N. Yeah. Second consolation goes to New Horizon Public School, Devashi Oja. Second prize goes to Presidency School, Kasturi Nagar, Divit Nagappa. The first consolation, KVNA School, Ashika K. B. Category B. Spot painting in the category B, the first prize goes to Ryan International School, Roshni H. Second prize goes to Presidency School, Kasturnagar, Tanisha Behra. Third prize goes to HL New Public School, Tanishka Sharma. First consolation goes to Surna Vidyalaya, Vaishnavi Krishna. Second consolation goes to Vagdevi Villa School, Marathahalli, Jagyasa Maharana. In the spot painting category C, the first prize goes to KVNL, Rasha KS. Second prize goes to New Horizons Public School, Arjun Deshmukh. Third prize goes to Vagdevilla School, Varturu, Anisha Ananyasi. I request all the students, please be seated. Kindly maintain the silence, please. Consolation, first consolation goes to NPS HSR, Sandana Gupta. Second consolation goes to Vagdevi Villa School, Whitefield, Anushri Pramod Nair. Now I request our honor of guest, Professor Shivarani Tirupati, to hand over the prizes to the students. Now next category. Please, kindly maintain silence, please. Now the next category, Science in Action. In the category B, first prize goes to Vagdevi Villa School, Whitefield, Bangalore, Ipsha Roth. Second prize goes to Shishu Guru Montessori and High School, Arya Pejayar Bhatt. Third place goes to National Public School, Bangalore, Sanvi, Abhijit. First consolation goes to Samant N. Naidu. Second consolation goes to CGIS New Tripasandra Bangalore, Abhay S. Halimard. Science and Action for the category C. The first prize goes to Harvest International School, Disha Prakash. Second prize goes to Sri Bashweshwara Primary School, Tumukuru, SB. Third prize goes to Presidency School, Kasturinagar, Arth R. The first consolation, National Hill View Public School, Pratyush Patil. Second consolation goes to AECS MMPS Arekere, A. Joan Aron. In the next event, extempore elocution for the category B. The first prize goes to Vagdavilla School, Satvik Satish. Second prize goes to Chitrakot Kaushalya School, Linay Aryan. Third prize goes to CND High School, Gaurav M. Nambiar. First consolation goes to National Hills View Public School, Vishwa Channu. Second consolation goes to Anand Shiksha Kendra, Arjun C. Shetty. For the next category of extempore elocution, for category C, the first prize goes to Vagdavilla School, Marathalli, Akshaya N. Second prize goes to Sri Kumaran Children Academy, Jasmita A. Third prize goes to PGS National Public School, Purika B. Kabadi. Puri B. Kabadi. The first consolation, Shishugriha Montessori and High School, Avika Sipani. And second consolation goes to National New Horizon Public School, Ayut Ilgur. Teachers. Yeah. For the next category, event, the Teachers Insight. The first place goes to New Horizon Public School, Ms. Radhika Rajesh. Radha Rajesh. Second prize goes to Bhakti Villa School, Bidadi, Miss Swati S. The third prize goes to Presidency School, Kasturnagar, Miss M.A. Pritalal. The second consolation goes to sorry. First consolation goes to Miss Lakshmi V. Ashok Leyland School, Osuru. Second consolation goes to Kottaswara Aided Kannada Medium High School, Mr. Lakshmikant Hirur. Thank you.
Thank you, sir. Thank you, sir, for facilitating the prize distribution ceremony. I request all the dignitaries to please be seated on stage. Thank you all. It's not winning that is the most important, but the spirit of giving your best. Congratulations to one and all, the winners and the participants. A big thank you to all the dignitaries for kindly distributing the awards. As we come to culmination of this event, this is the time we offer our gratitude to one and all who made this event meaningful and successful. May I now request Shri K. Vishwanath Sarma, Member Secretary, NSD 26 Organizing Committee, to deliver vote of thanks.
Thank you. Respected Director URSC, Chief Guest Professor Ajit Parameswaran, Guest of Honor Professor Sivarani Tirupati, Chairperson of the NST Organizing Committee, URSC dignitaries, fellow scientists, teachers and my dear young friends. As we conclude this magnificent celebration of science, it is my privilege to propose the vote of thanks on behalf of the organizing committee. A profound thanks to our chief guest, Professor Ajit Parameswaran, and our guest of honor, Professor Sivarani Tirupati. Your presence today has truly elevated the spirit of this function, and your insights have undoubtedly sparked a scientific flame in the minds of young winners. I express my deep gratitude to Director URSC for his unwavering support and vision that allows us to host such large-scale outreach programs. We owe the success of this event to the enthusiasm of 865 participants from various schools spread across the region. I would like to specifically thank our subcommittees who worked untiringly over the last month. The C&MG team and stage management team led by Ananta Shainam GR for the flawless infrastructure and the beautiful decoration of the Satish Dhawan Auditorium. The canteen and catering team led by Satyanarayan Pandey for ensuring high hygiene standards and providing meals for over 1,000 people. The Budget and Prize Committee led by Sujaji for meticulously arranging the certificates, mementos and gift cards for our various winning entries. The Web Committee led by Ananta Satawale for their digital support during registration and post-event phases. And Brochure Committee led by Bhanu Basin for their creative support that reached all our participant students in the form of their badges and certificates. The Reception, Logistics and Transport Committee, led by Sanjeev Kumar KS, for organizing the registration of hundreds of students and catering to the logistic requirements of the events. Outreach Committee, led by Prasad BS, for reaching out to the students belonging to schools across the region and being a strong support to fellow committees. All the 7 event committees, starting from model making by Sharanappa S, test of scientific temper by Ravishankar BT, teachers event by Revanna K, extempore elocution by Rupali Sahu, spot painting by Anita BR, science in action by Chidambar Kulkarni, science quiz by Vishwanath M. Tillapur, who have put their best efforts in making the events challenging and at same time enjoyable to the participants. To all our volunteers belonging to scientific, technical and administrative staff and all other supporting staff whose patience and dedication in managing these many participants made the events of February 21st possible. A special thanks to CSF Security for ensuring the safe movement of hundreds of students and school buses within our campus, and also fire and CHSS entities for their support during the events. As we celebrate this year's theme, Women in Science Catalyzing Viksit Bharat, let us take the spirit of inquiry we witnessed today back to our classrooms and labs and fuel one amongst you to be the next Indian citizen to bring back the glory of Nobel Prize after Sir C.V. Raman. Thank you one and all for being a part of National Science Day 2026.
Thank you, sir. With this, we come to the end of the valedictory function of National Science Day 2026. We appreciate the interest and participation of the students, teachers, dignitaries, organizers, volunteers, and URSC management. Thank you one and all. Keep dreaming and keep exploring. Lunch has been arranged and will be available in main canteen. Volunteers will be able to guide you through main canteen. Thank you all. Sir, I request all the dignitaries for a group photo.